Hold two magnets in your hands, North Pole to North Pole. Push them together and feel that resistance, that invisible wall in empty air pushing back against you. You want to know what's between them. But here's what you don't understand yet. Your question is broken. Not wrong. Broken. And until you see why it's broken, every answer you get, including this one, is going to feel like a dodge, like I'm hiding something from you. I'm not. I'm about to show you that the thing you're asking for doesn't exist. You're looking for an explanation, something familiar, something that makes magnetic repulsion feel like pushing on a spring, or rubber bands stretched between invisible hooks, or two hands pressing against each other. You want me to say, magnets repel because of X, where X is something simpler than magnetism itself. Something you already understand, but there is no X. And this isn't me being difficult. This isn't me hiding behind complexity or waving equations at you to make you go away. This is the truth, and it's more unsettling than you think. Because what exists between those magnets? Nothing. And everything. And neither. And you need to sit with that discomfort for a moment, because that discomfort is the beginning of actually understanding. Let's start with what you think you know. Push your hands together right now. Palm to palm. Push hard. Why don't they pass through each other? You'll say, because they're solid. Wrong. Not wrong because your hands aren't solid. They are. But wrong because solid is just another word for the thing you're trying to understand. It's a label, not an explanation. Try again. Why don't your hands pass through? So because the atoms are packed together better. But now why don't the atoms pass through each other? This is where most people get stuck. They say because atoms are solid too, but atoms are not solid. Not even close. An atom is almost entirely empty space. If you scaled an atom up to the size of a football stadium, the nucleus would be a pea at the center. The electrons would be tiny specks way out near the seats. Everything in between? Nothing. Your hand is essentially empty space. This desk is essentially empty space. So why don't they pass through each other? You're uncomfortable now. Good. Stay there. The answer isn't what you want it to be. The answer is electromagnetic force. The electrons in your hand are negatively charged. The electrons in the desk are negatively charged, like charges repel. And that repulsion, that's what's keeping your hand from passing through the desk. But wait, that's what you were asking about in the first place. Why do magnets repel? And now I'm telling you that your hands don't pass through things because of electromagnetic repulsion. So we're right back where we started. You want to know why electromagnetic forces exist. And here's the problem. Electromagnetic forces are fundamental. They're rock bottom. There's nothing underneath them. Richard Feynman, Nobel Prize winner for his work on quantum electrodynamics, the guy who literally developed the most precise mathematical description of electromagnetic forces in history, was once asked this exact question by a BBC interviewer. Why do magnets repel? And his response was so uncomfortable for the interviewer that it became legendary. See, Feynman didn't answer with fields or electrons or photons. He challenged the question itself. He said, essentially, you're asking for something I cannot give you. Not because he didn't know, but because what you're asking for doesn't exist in the universe. Think about it this way. You can explain why a ball rolls down a hill. Gravity pulls it downward. But why does gravity pull things downward? You can say mass curves space-time. But why does mass curve space-time? You can invoke Einstein's equations, quantum field theory, the Higgs mechanism. But eventually, no matter how deep you go, you hit something that just is. A fundamental law. A bedrock truth about how reality works that cannot be explained by appealing to something more fundamental, because nothing more fundamental exists. For magnetism, that bedrock is electromagnetic force. Well, it's not like anything else. It is itself. And everything else, the way atoms hold together, the way light moves through space, the reason your hand doesn't fall through the desk. All of that is explained by electromagnetic forces. But electromagnetic force itself, it just is. You're thinking, but I've heard explanations. Magnetic fields, electrons spinning, virtual photons. Those sound like deeper explanations. No, they're descriptions. And you need to understand the difference, because the difference is everything. A description tells you how something behaves. An explanation tells you why it exists. When physicists talk about magnetic fields, they're describing the pattern of forces around a magnet. When they talk about electrons having spin, they're describing a property that generates magnetism. When they invoke virtual photons, ripples in the electromagnetic field that mediate forces between charged particles, they're describing the mechanism. But none of this explains why electromagnetic force exists in the first place. It just tells you how it works once you accept that it exists. Here's where it gets really disturbing. In modern physics, the deepest level we've reached isn't particles, it's fields, invisible, continuous substances that permeate all of space. There's an electromagnetic field spread throughout the entire universe. There's an electron field, a quark field, a Higgs field, and particles, the things you think of as the fundamental building blocks of reality, those are just ripples in these fields. An electron is a localized disturbance in the electron field. A photon is a ripple in the electromagnetic field. When you push two magnets together, what's between them is a disturbance in the electromagnetic field. Not particles flying back and forth like tiny tennis balls, not invisible strings or springs, a disturbance, a configuration of the field itself that creates force. But here's the thing that breaks most people's brains. The field is not made of anything. It's not a substance in the way you understand substances. It's more fundamental than that. It's a mathematical object, a function that assigns values to every point in space and time. And yet, it's also physical. It carries energy. It exerts force. It's the most real thing in the universe. And it's also utterly unlike anything you can point to and say, there, that's a thing. This is what Feynman was trying to get the interviewer to understand. When you ask what's between two magnets, you're asking for a thing, a substance, an object, something tangible. But what's between them is a configuration of a field. And fields are not things in the way you want them to be things. Now you're thinking, okay, but what is a field made of? Stop. You're doing it again. You're looking for something underneath, some deeper layer that will make fields make sense in terms of something more familiar. But there is no deeper layer. Fields are the deepest layer we've found. They might not be the absolute bottom. Maybe there's something beneath fields that we haven't discovered yet. But as of now, in 2026, fields are as fundamental as it gets. Asking what fields are made of is like asking what numbers are made of. Numbers aren't made of anything. They're abstract objects that we use to describe relationships and quantities. Fields are similar, except they're also physical. They're abstract mathematical objects that also happen to be the structure of reality itself. Let's go back to those magnets in your hands. You push them together. You feel resistance. What you're feeling is the electromagnetic field in a particular configuration, a configuration that produces force. The field is disturbed by the presence of these two magnets, both of which have aligned magnetic domains, which means their electron spins are coordinated, which means they're collectively disturbing the electromagnetic field in a specific pattern. When these two patterns overlap in space, the field configuration changes, and that change manifests as force. Not because something is physically between the magnets pushing them apart, but because the field itself, in this configuration, generates force. But you want to know why. Why does this field configuration generate force? And here's where we hit the wall. Because the answer is, that's what the electromagnetic field does. That's its fundamental property. It's written into the mathematics that describes the field. The field obeys Maxwell's equations, which tell you how electric and magnetic fields relate to charges and currents. Those equations predict that like charges repel and opposite charges attract. They predict that moving charges create magnetic fields. They predict electromagnetic waves that propagate at the speed of light. All of this is encoded in the equations. But the equations themselves? They're not derived from anything deeper. They're fundamental laws. We discovered them by observing nature, by measuring how charges and magnets actually behave. And we found that these specific equations describe that behavior with extraordinary precision. Quantum electrodynamics, the theory Feynman helped develop, predicts the electron's magnetic moment to more than 10 decimal places. It's the most accurate theory in all of science. But even that theory doesn't answer why. It just describes how with mind-bending precision. This is the uncomfortable truth. At some point, explanations stop. You hit bedrock. And for electromagnetism, that bedrock is the electromagnetic field and the laws that govern it. You can ask why other things happen, why your coffee mug stays together, why the sun shines, why chemical bonds form, and you can trace all of those back to electromagnetic forces. But electromagnetic force itself, that's the foundation. There's nothing underneath it to compare it to. Here's the thing that makes this less depressing than it sounds. This is actually what understanding means in physics. Understanding doesn't mean everything reduces to something comfortable and familiar. Understanding means you found the laws that let you predict what will happen. You found the patterns. You found the mathematics that describes those patterns with precision. And from those patterns, you can build up explanations for everything else. You don't need to know why electromagnetic force exists to understand how it creates atoms, molecules, chemistry, biology, consciousness, and every technological marvel we've built. You just need to know the rules. And we know the rules extraordinarily well. When you hold those magnets and feel them push apart, what you're feeling is one of the 4 fundamental forces in nature revealing itself in your hands. The electromagnetic force is responsible for essentially everything in your daily life except gravity. It holds atoms together. It creates chemical bonds. It lets light bounce off objects so you can see them. It carries the signals in your nervous system. It's the reason matter takes up space at all. And yet, for all its ubiquity, it remains fundamentally inexplicable. Not because we don't understand it, but because there's nothing more fundamental to explain it with. This is where Feynman's answer becomes truly profound. He wasn't dodging the question. He was showing the interviewer, showing all of us, that the question itself reveals a misunderstanding about how knowledge works. We want reality to be like Russian nesting dolls. Each layer explained by a smaller layer inside, and inside that an even smaller layer, until eventually we find the tiniest doll that explains everything. But reality isn't like that. Reality is more like a tower, where each level is built on the level below, and electromagnetic forces are one of the bottom levels. There might be something beneath it, maybe strings, maybe loop quantum gravity, maybe something we haven't imagined yet, but whatever is at the bottom isn't going to feel familiar. It's going to be just as strange as fields are strange. Because fundamental things, by definition, cannot be explained in terms of anything more familiar. They are what all the familiar things are made from. So, what's between 2 magnets? A configuration of the electromagnetic field. A disturbance in an invisible continuous substance that fills all of space. A mathematical object that's also somehow the fabric of physical reality. A pattern encoded in the universe's deepest laws that produces force when disturbed in specific ways. And if that doesn't feel like a satisfying answer, if it doesn't feel like I've really told you what's there, then congratulations, you're starting to understand. Because the discomfort you feel, that absence of the comforting analogy you wanted, that's not me failing to explain. That's you glimpsing the actual structure of reality, which is stranger, deeper, and less like your everyday experience than you ever imagined. The truth is, we don't get to choose what reality is like. We don't get to demand that it makes sense in terms of things we're already comfortable with. We only get to discover what it actually is. And what it is, at the deepest levels we've reached, is fields. Continuous, invisible, mathematical yet physical entities that permeate space, and whose ripples and disturbances are what we call particles, forces, and everything else. You wanted to know what's between the magnets. Now you know. It's a field, and fields are not like anything else. They're the thing everything else is like. This is what understanding actually means. Not comfort, not analogy, not reduction to something simpler, but predictive power, mathematical precision. The ability to say, if I do this, the field will respond like that, and the force will be this much, and the trajectory will go here. We can predict electromagnetic phenomena with absurd accuracy. We've built our entire technological civilization on that understanding. Your phone, your computer, your car, the electrical grid, medical imaging, GPS. All of it works because we understand electromagnetic forces well enough to manipulate them with extraordinary precision. We don't need to know why the electromagnetic field exists. We just need to know how it behaves, and we do. So here's what Feynman was really saying, what he was really trying to get that interviewer to grasp. Your question demands an answer that doesn't exist. Not because physics is incomplete, but because you're asking for something underneath the bottom. You're asking me to explain arithmetic using something more basic than numbers. Can't be done. The electromagnetic force is fundamental. It's one of the deepest truths about how reality works. And the fact that it can't be explained in terms of springs or rubber bands or anything else you're familiar with, that's not a bug. That's the feature. That's what fundamental means. What's between two magnets? The electromagnetic field, disturbed. Why does it create force? Because that's what it does. That's what's written into the fabric of reality at the deepest level we can probe. And if you can sit with that, if you can let go of the need for something more familiar underneath, then you've just understood something profound. Reality doesn't owe you comfort. It only owes you truth. And the truth is strange.